Okay, I'm going to help you out with 2.6 tables and graphs review. So some of you kind of got stuck on what to do, and so you asked if you can get a little more help on it. So I'm going to try and do that for you. Hopefully by the time we're finished here, you can watch it a couple of times and then you have a better understanding of how to do this. So basically what we're doing is you're being given a table of X and Y values. Remember, these make coordinate points, and the coordinate points are what we use to graph to determine what kind of line we're dealing with. Remember, we talked about that with algebra. Everything in algebra has to do with a line. And remember that a table isn't created by itself. It's created with equations. You have your equations, and we use our equations to plug in values and make our table. And our table makes ordered pairs for which we can make our graph. So you need to know how to work interchangeably with each one, a graph, a table, and an equation. So the first one that we worked on, you have your X values like 12, 13, 14, and 15. And again, the table is given. And then the Y values are 9, 10, 11, and 12, say, okay? Then I said to you, all right, I'm going to give you 4 equations. Y equals X plus 3, Y equals X divided by 3, Y equals 3X, and Y equals X minus 3. And then I said, which one of these equations matches this graph? Or I'm sorry, matches this table. So what you want to do is you want to notice again that you have X and Y values. So here's your X values right here. And then here's your Y values. It's just about substituting into the equation. So every time I see an X value, I'm going to substitute it for my X's. So there's all my X's. So I'm going to go ahead and plug in the value that I have here for X with the hope that I'm going to come up with, when I plug it into the equation, I'm going to look to see, do I come up with the Y value that I want? Because remember, this is an ordered pair. This is ordered pair 12, 9 on a graph. This is ordered pair 13, 10. This is ordered pair 14, 11, and this is ordered pair 15, 12. If I graphed this, this would make a linear line. I go over 12 on the X, I go up 9, I put a point. I go over 13, I put up 10, I put a point. Over 14, up 11. Over 15, up 12. It's creating this nice linear line, okay? So my X value is 12. I'm going to substitute it in for X and evaluate. Remember, we've been doing this since chapter 1, substituting and evaluating. So in this case, when X is 12, so I'm going to put 12 here, I'm going to do the problem. 12 plus 3 equals 15. Does it equal 9? No, it equals 15. So it didn't work. I want Y to be 9, not 15. So this one didn't work. Then I'm going to do it again. But this time I'm going to go to this problem. And I'm going to substitute X for 12. 3 times 12 equals 36. Did it equal 9? No, it equaled 36. So that one didn't create the line that I wanted. So I'm going to go to this one. I'm going to substitute 12. 12 divided by 3 equals 4. Did it equal 9? Nope. It equaled 4. So that didn't create the table. Let's check this one. 12 minus 3 equals 9. Did it equal 9? Yes. This is the equation that created the table. So you're just substituting your X values in. So let's do it again. So I have X and I have Y. And for my X values, I'm going to put 2, 1, 0, -1. And I'm going to put 6, 5, 4, 3. My equation choices are Y equals X, y equals x minus 4, y equals 5x, and y equals x plus 4. So again, I have my x values right here, and I have my y values. I'm going to substitute my x values in for x with the goal of getting the y value that connects with that x. So if you look at it, there's your ordered pairs right there. So I can even do this to show you. Those are my ordered pairs right there. So first one is 2. I'm going to go ahead and substitute 2 in here. And I want to know, does 2 equal the y? Well, y is supposed to be 6. So I would put 6 here. Does 2 equal 6? No, that didn't work. So then I'm going to substitute it up here. 5 times 2 equals 10. Okay? 5 times 2 equals 10. Did it equal 6? No, it equals 10. I want it to equal 6. That didn't work. So this one, I'm going to substitute 1 here. And you know what? I could go ahead and pick any one of these values I want. I don't have to pick the first one. So let's do a different one. Let's substitute 1 in right there. So I'm going to put 1 in there, and I want this to be 5, okay? Does 1 minus 4, does that equal 5? No, that equals -3, so that didn't work. This one, I'm going to go ahead and substitute 0 in here. See, I'm using this one now. It's the easiest one. I'm going to put 0 there, and I want it to equal 4. Right there. Does 4 plus 0 equal 4? Yeah, so this one worked. So maybe it would be better if you put what the y is supposed to be and what the x is, and then look to see if you would say it's true or false. So like for this one right here, instead of putting what it actually equals, I'm going to put who goes with 2, 6. And then I'll look at this and go, does 5 times 2 equal 6? No, it didn't work. Just like I did with this one. So who goes with 1? 5 does. So x is 1 and 5 is y. Is 1 minus 4 equal to 5? No, it's not. Okay? And notice I didn't have to use just the first one. I used this one for this one. I used this one for this one. So you could use various ones. You don't have to use the same one each time. So let's do another one. Here's x, there's y. And let's go 0, 1, 2, 3. And let's go 5, 6, 7, 8. Y equals x plus 5. Y equals x minus 5. Y equals 5x. And then x equals y minus 5. So again, pick any one of these that you want, okay? I'm going to choose this one, and I'm going to substitute this for x and this for y. So I'm going to put 0 here, and I'm going to put 5 here. Is 0 plus 5 equal to 5? It is. So I'm going to check another one. I'm going to put 1 in for x, and then y has to be 6. Is 5 plus 1 equal to 6? It is. Geez, I don't need to go any further. But just for the sake of testing, I'm going to try this. Does 5 times 0 equal 5? Because see, 0 and 5 go together. 5 is the y, 0 is the x. And no, it didn't work. So I know that doesn't work. Let's try this one. 0 minus 5, does that equal 5? Nope, it equals -5. So that didn't work. This one, I put 0 here and 5. Actually, this one works for this one too. Let's put 1 here. Nope, sorry, that should be a 6. Make that. And then this would be x, which is 1. Is 6 minus 5 equal to 1? It is. So it looks like this one has 2 solutions, 2 different equations that will work. Let's do it again. Let's do this one. Let's do this one. -1, 2, 5, 7, then -3, 9, 21, 29. X, y, I have y equals 4x plus 1, y equals negative x plus 9, y equals 1/4 x minus 3, and y equals negative 3x minus 1. Okay, so I look at these numbers and I'm going to try to pick an easy one. I kind of don't want to pick the ones with negatives because then I have to deal with knowing those rules. So I'm going to pick a positive one right here, and I'm going to substitute it in. Right here, I want x to be a 2, so it'll be times 2, and I want y to be 9. So let's see if it works. 4 times 2 is 8, plus 1 is 9. Holy cow, it worked on the first try. So there we go. I don't need to go any further. I could test another one. 4 times, I could do the 4 times 5. 4 times 5 is 20, plus 1 is 21. And that worked too. So there you go. It's that one. So that worked for that. When I needed to find substituting a number, I just would look for a pattern. So I hope that helped more of doing tables and graphs, giving you a better idea of how you are supposed to substitute in the x and find the y value. So you're just working through what we did in chapters 1 and in the beginning of chapter 2 when I said, here's the equation, evaluate when x equals blank. Okay, so make sure you take a look at this again, and hopefully you have a better understanding of how to match a table to an equation.